So good morning once again. Today we're going to continue our discussion on simple interest and move on to simple discount. Okay, so last time we said that simple interest is easy to recall. The formula is simply interest. I hope this works. Oh. Okay, sorry about that. Okay. I'm having problems with my digital pen. Okay, let's see. I hope this works. Okay, so very quick review. Okay, so in order to compute for the maturity value, we just add the principal and the interest. And the interest is simply your principal times your rate times your time. Okay, so we looked at this last time. Okay. Is the screen visible, guys? Is the screen visible? Can you see? Okay, thank you. All right. So, hold on. So what we learned last time was that if your rate is stated in months, then your time should be in months. There should be consistency as far as the use of your rate and your time. Oftentimes, when rate is given, it is given in annual figures. Okay? If you, for example, see 3%, automatically you assume that that's annual. And do not do otherwise unless it's stated that 3% monthly. Okay, so we looked at some basic problems. Just a quick review. If you're borrowing, for example, 40,000, and then the interest rate is 4%, and then the term is just 6 months. Okay, so this is the simple formula: principal times rate times time. The rate is stated yearly, and the term should be stated also yearly. So it's 6 months, which means if you convert it into a year, that's 6/12. Okay, so that's what we were looking at last time. Okay, so to compute for the maturity value, we just add the principal and the interest. So that's principal plus the interest, or if we simplify this, you can do this: principal plus the interest is principal times the rate times the time. right? So we can factor out your P. So this becomes the maturity value is equal to your principal times 1 plus RT. Okay? So this is your simple interest, this P times RT. All right, so to compute for the maturity value, you just multiply your P with this factor 1 plus R times T. All right, so we can try that here. So maturity value is equal to P times 1 plus RT. And our principal is 40,000. 1 plus the rate at 0.04. And then our time is, that would be times 6 over 12. Okay. So if we perform this, we will get 41,600. Okay, let me pause for a while. Any questions about this formula? The maturity value is equal to, is the product of your principal times the factor 1 plus RT, which is just the same as adding your principal and your interest. Any questions, guys? Okay, let me put it another way. Clear so far? Is our explanation clear about the computation for the maturity value? Okay, thank you. I hope everybody will. Okay. I'd like to wait for the others to give their feedback. Okay. If you have any questions, class, feel free to ask your questions. And I'm going to give you a copy of this with the writing. Okay. Okay, thank you very much. All right, so let's continue. Okay, this is again a very quick review, another review. Last time we looked at this problem also. This time, the term is 18 months. So just like the first problem, we just multiply the principal times the rate times the time. And the time should be also in years. The rate is in years, the time should be in years. And since we're given 18 months, we have to convert this into years by dividing it by 12. So same thing. So we were able to compute for the interest here, principal times rate times time. So that's 2,400. And then add it to the principal to get the maturity value of 42,400. And we can do this straightforward. Principal times 1 plus RT. Okay, so that's 40,000 multiplied by 1 plus 0.04 times the time is 18 over 12. If we perform this, we will get the same 42,400. Okay, so we can illustrate that in Excel. Let me just open Excel. So let's just validate. So this is our principal, and this is our rate, then our time. Okay, this is 40,000. Our rate is 0.04, and then our time is 18. Okay, so our maturity value will then be equal to, it's the, let me increase this so you can see. Okay, it will be equal to your principal times 1 plus your rate is this amount times your time is 18, but that has to be converted into okay, that has to be converted into years. Okay, 1 plus rate times time. There will be no problem with this in Excel because Excel will first multiply and then add 1 plus the rate times time and then multiply it with the principal. Okay, 42,400, which is the same comparing to the answer here. Okay, and then I think I did not mention to you last time that we will be learning tricks in Excel. So may I ask you who among you have used the named range function of Excel? Named range. Any one of you have used the named range functionality of Excel? Kindly chat, please. Yes or no? Named range. Have you used this before? Okay, good. Good, thank you, because this is an opportunity to learn. All right, let me teach you a simple trick on how you can make use of named range. This is just a simple trick. All right, this one. Okay, thank you. This number here, 40,000. This one, the address of this one is C3, as you can see here. This is the name box. It's C3, column C, row 3. This one is, of course, C4, and then this one is C5. Okay, but what we can do is change the name of this particular cell. I don't want this to be called C3. I want it to be given a name. So what name could I give it? I can call this the principal. So how do I name this cell C3 principal? Well, that's very easy. You go to this particular cell, C3, and then just type here principal. Okay, principal, and then enter. And then if you go to your name boxes, you now have principal. So this cell is no longer C3, at least for this worksheet. It's called principal. So, and how about this one? The rate. Let's also give it a name, rate. Okay, rate, enter, and then also the time. Let's give this a name, time. Time, enter. Okay, so you notice that this one is now called rate. This one is called time. This one is called principal. So what we did was to make it name it one at a time. But if your data is arranged this way so that the names are on the left side or on the right side or wherever, I could have highlighted this and then, okay, and I could have typed, let me write that here, Control plus Shift plus F3. Control Shift F3. Now in Mac, kindly check. I'm not sure. I think it's command function F3. I'm not sure. But if you highlight this, the names are on the left side. The values are here, and we would want to give these names to these particular cells. I highlight this and then Control Shift F3. I would be getting this. Create names from the values in the, and Excel rightly guesses that it's in the left column. Okay, and if I click OK there, then the names will all be here. So it didn't change because we already did that. But this was a shortcut. You can just highlight everything and then use Control Shift F3. Anyone using Mac? For the benefit of your classmates who are using Mac, if you highlight this, and then what's the command for that? Is it Command Shift F3. Anyone please using Mac? Could you share please to the class? Hello, anyone using Mac? None? Okay, so I'm assuming no one's using Mac. So Windows has Control Shift F3, and automatically this cell is already named principal, this cell is named rate, and this cell is named time. Now this is especially useful if you keep on using, if you keep on using this particular cells as absolutes. So if I delete this, okay, so let's now use this in a formula. So it's principal times rate times time. So I can use P, principal, so it doesn't show here R. And now you can see here, it's a spreadsheet principal. This is now the cell that we use, okay? Tab. So we find your principal and it links to your 40,000 times 1 plus, okay, your rate, let me type RA. And here you have your rate, right? And then times your time, there, time. Then we have to divide it by 12 because the time is in months, right? So it's now more intuitive, principal times 1 plus rate times time, instead of just using the generic C3 plus etc., etc. And what's good about this, Control Enter, is that anywhere you are here, let me open several sheets. Okay. So suppose I need a value of the principal. Okay, so I'm in sheet number 6. I can just type PR there, principal. Okay, and it will give me the 40,000. So this name principal works in all the worksheets. Okay, unless there's a conflict, and we'll just discuss as we go on what happens if in this sheet you have another object named principal also. Okay, then the one in sheet 6 will prevail. But globally, for all the other sheets, this name principal will stand for this one. Okay, let me pause again. And I would that you please answer. Are we able to follow? Is it clear? The use of named range, giving names to particular values. Okay, so let's wait for the others to respond. Okay, good. Thank you. Thank you, guys. Thank you for your participation. And salamat. And again, let me encourage you, if you have any questions, please feel free to ask questions. Please don't be ashamed. This subject, our environment here is safe. You will not be ostracized. You will not be put to shame by asking questions. So please feel free. Okay? Please feel free to ask questions. You are highly encouraged to do that. And no question will be regarded as here the word stupid does not exist. Okay, there's no one here who's stupid. There's no stupid question. Okay, everyone is encouraged to ask questions. Okay, that's very good. So we learned, as we go along class, we're going to learn tips and tricks on how to make the use of Excel really optimal and very efficient. Okay, imagine if I was here and then I would have to refer to, I would have to find that principal in sheet 1. If I did that, enter, okay, it will still be named principal. All right. Let's continue with our discussion. Okay, now we started looking at the two types of interest. Okay. I mentioned it here. Okay, so first we have exact interest. When you say exact interest, your divisor will be 365. Okay, so we're counting the days and then divided by 365 to convert it into year. Okay, because the number of days divided by 365 will give us the term or the time in years, and then we can multiply that now with the annual rate. So we did this last time. Okay, so our problem was on March 4, Bench borrowed 50,000 at 5% interest. The interest and the principal are due on July 6. What are the interest cost and maturity value? So let me copy this, Control C. Let's put it here. Okay, so let's identify our parameters. Our principal, let me just call it P. Okay, our principal is 50,000, and our rate, let me call it R. Rate is at 5%. Okay. What's different here is that you're given a specific date, March 4, okay, and July 6. March 4 and July 6. Now, how do we now compute for the interest? Okay, so let's compute for the interest separately first. Ri, okay. Ri we know to be your P times R times T. Now, what's our T? What will be our T? So the term is from March 4 to July 6. The question is, how many days are there from March 4 to July 6? So let's start counting that first manually. Okay, so March, start with March 4. So from March 4, for the month of March, how many days, actually not days, but periods. How many periods are there? When you say periods, for example, from March 4 to 5, that's one period. And then 5 to 6, and then 6 to 7, 7 to 8, until 30 to 31. If you're going to count that, how many periods are there? Let me illustrate that. 4, 5, 6. So when we're counting interest, we're counting periods. Just to be clear. Okay. How many periods are there from March 4 to March 31? Okay, so how do we count this? From 4 to 5, that will be 1. Okay. March 4 to March 5 will be 1 period, right? And then March 5 to March 6, that will be another period. So it will be 1, 1, 1 until March 30 to 31. Okay. So those are the number of periods. And if we sum all of this, okay, that will be 27 periods all in all. Or the shortcut is just subtract 31 by 4. So 31 by 4, that gives us the number of periods. So for the month of March, there will be 27 periods. Okay, how about for April? For the whole month of April, how many periods? How many? Okay, 30, that's correct. 30 periods for the whole month of April. For May, how many periods for the whole month of May? That will be 31. For June, that will be 30. And then for July, July is up to July 6. How many periods will there be from July 1 to July 6? 1 to 2, 2 to 3, 3 to 4, 4 to 5. Okay, how many? will be 6 periods, right? So if we add this sum, okay, 124 exact periods between March 4 and July 6. All right? So our interest will be based on 124. So this is the number of days. Number of days is 124. Therefore, our interest will be equal to, okay, so it's the principal times the rate. Take note, the rate is like an annual rate. And then so the days is 124. Okay, and then we have to convert this into annual by dividing it by the number of exact days, 365. Okay, enter. So this one is exact. Okay, so if it's exact, no, we're use 365 days per annum. Okay. Let me put here. Okay, total periods for March is 27. Okay, so let's see, get formula. No get formula here. Bucket. Formula text, sorry. Formula text. Okay, to show the formula. Let me fix this. I'll share this Excel file with you. Okay, any questions so far? Yeah, 6, that's correct. Yes, Daniel?
Sir, I got lost po.
Yeah,
How
sure.
did you get 849.3 po?
Okay, sige, let me repeat that. Okay, so here we're computing for the interest. Thank you, Daniel, for that question. I really appreciate that. So we compute for the interest, and we know that the interest, the formula for the interest is principal times rate times time. So we just follow that formula. And then our principal is 50,000. Our rate is 5%. And here we are, it's not written here, but we want to compute for the interest using exact days. Okay, for exact days, we have to use 365 as our divisor. Okay, so our interest will now be the principal, which is 50,000, times the rate, which is 5%, times how many days are there between March 4 until July 6. Actually, the more correct question is how many periods. Okay, how many periods from March 4 to July 6? And we counted the number of periods. We got 124 periods. Okay, so this will be the number of periods that will be subjected to interest. And since this is days, we have to convert that into years. Kasi our rate is at 5%, it is in terms of years. Therefore, our time should also be in years. So 124, you convert that into years using 365 if we're using exact. Okay, here. We're using exact interest. Therefore, we use 365 days. That's where we got 849.32. Okay, so it's 50,000 times the rate of 5% times the exact number of days, 124, divided by 365. Okay, let me pause for a while. Daniel, did that answer your question?
Yes, sir. Thank you, Bob.
Okay, thank you. Thank you, Daniel, for that question. Okay, so I'm happy, guys, if you're asking questions. Okay, please feel free. Are there any more clarifications? Any questions? All right. Actually, in Excel, and since we're going to make use of Excel, let's see what happens if we, okay, let me insert, oops. Let's see what happens if I subtract July 6 minus March 5. Can we get that? Okay, see, it's automatic in Excel. July 6 minus March 4, that gives us 124 periods between July 6 to March 4. And we need not have manually counted it. But it's okay because because at least we know how we got this. Okay, I have one question with you guys. Okay, here for March 4 up to March 31, what we did was to subtract 31, March 31 minus March 4, so that's 27 periods. How about for this one? April 1 up to 30. Okay, so that should be 30 minus 1, that should be 29. Why is this 30? Shouldn't this be 29? Because if we're subtracting April 30 minus April 1, shouldn't that be 29? No, but why is this 30? Okay, any suggestions? Why is that is 30? So let me backtrack. Here, March 4 up to March 31. Okay, so that's March 31 minus March 4, that's 27. This is okay. How about for April? April 1 up to April 30. Isn't that 29? How about for May? May 1 up to May 31. Shouldn't that be 30 periods also? Also for June, shouldn't that be also 29? Also for July, shouldn't that be 6 minus 1? Shouldn't this be 5? So what's happening here? Yeah, thank you, Bianca. Yeah, days of April, but we are counting not the days, we're counting the periods. Okay, take note that what we're counting is the number of periods, not the number of days. Yes, Gerard, you were raising your hand. Yes.
I think you count the period from the previous month to the next month as one.
Okay.
So from March 31 to April 1, that's one
Yeah,
period.
very good. Thank you, Gerard. That's correct. Okay, that's correct. Okay, let me illustrate that. What Gerard said was, so this is March, right? This is March. Now in April, so this is the start of April. Okay, so we start with 1, right? Now there's also one period between March 31 and April 1. So that's one period. Okay, and then if we go to 2, 1 to 2, that's another period. Okay, so if we're going to count the number of periods, then we also have to count the period between March 31 to April 1. All right? That's why if we're starting with the month, we should not be subtracting. Okay, because this is continuous. Unless we're starting with April 1. All right? So I hope that's clear. If we're starting with April 1 up to April 30, how many periods are there? There will only be 29 periods if we're starting with April 1. I hope that's clear, class. But we're not starting with April 1. We're actually starting with March 4. So there is one period between March 1 and April 1. So that's considered as one period also. Okay, so that if we reach up to 30, let's say we're 30 here, we actually have 30 periods because we're not starting to count at April 1. We're starting to count from the previous month, as mentioned by Gerard. All right. But if we are only starting with April 1, I hope this is clear. There are only 29 periods here. Okay, and not 30. There are 30 days, but 29 periods. So if you count 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, etc., how many periods will you have? You will have only 29 periods. Okay. All right. I hope that's clear. Take note of the beginning time and the ending time. In Excel, that's very easy because you can just subtract. All right. So let's go back to our PowerPoint. Okay. So here we determine the number of periods, and then based on the exact days, we are going to divide the number of days by 365. Okay. How about if it's ordinary? Because you have the difference between exact and ordinary. For ordinary, you don't use 365. You just use the average of 360. So that's 30 days per month times 12. So that's why you have 360. Okay. And the interest will be higher if it's ordinary interest. Why? Because the divisor is lower. 365 for exact, 360 for ordinary. So because you have a smaller divisor, then you have a higher interest rate. Okay, so if we do the same for this problem, okay, so let's do that in Excel. By the way, the maturity value will be equal to the principal plus the interest. Okay, so I'm putting here the formula so that you can see. By the way, the formula there, the function there is formula text. Okay, so that you can see the formula beside. If you want to see where we are getting these values. Okay, of course we could have gotten that by, the shortcut is equal to the principal times, principal is equal to principal times, open parenthesis 1, plus your rate, okay, times your time, which is 124 divided by 365. Okay. Oftentimes, class, it's not good to put absolutes here. If I were to do this, I would have. Okay, so let me do that. I would have inserted here. I would have inserted here exact. For exact, I would have made this 365, and then for ordinary, I would have used 360 here. And then I could have given this a name. Okay, I could have given this a name. So if I were to change this, this would be equal to principal times 1 plus your rate is 5%, and then times how many days? 124 days divided by, you're going to use exact, so that should be 365. Okay. And then let's see for ordinary. Same formula. The only difference, let's compute for the interest also. And then you'll see that the interest will be bigger, will be higher because you're using a smaller divisor. This one we can replace this by 365. Okay, so now it's all linked to particular cells. As much as possible, do not use absolutes in your cell formulas. Separate the givens. Okay, so that if the given will change, then automatically you can just change the given. It will link to your formula. So the interest will be equal to the principal times the rate, 5%, times the time. It's also 124, but this time we divide it by 360. Okay. So as I mentioned a while ago, the interest will be higher if it's ordinary because the divisor is lower at 360. So the market value for this one will be, if you just add, it will just be equal to the principal plus the interest. Okay. And we know it will be higher than the exact interest, or you can use the direct formula. It's equal to principal times 1 plus your rate times your time, which is 124 divided by your number of days is 360. Okay. And there you have the formulas. Okay, let me pause for a while. Any questions? I'll give you time if you're following along. Okay, yeah. There's a question here by Diana. Okay, let me just copy this. All right. So Diana's question here is you need to start counting the period from March 31. Yes. Yes, because it's continuously happening, right? From March 4 up to July 6. So you will have to also count the period from March 31 up to April 1. That's one period. That's why in April we were counting 30 periods because we started counting from March 31 to April 1. That's considered as one period. That's why we had the full count of 30. Otherwise, had we started only at March 1 to 2, April 1 to 2, that would be one period. So that will only be 29 periods if we're starting with April 1 up to April 30. From April 1 up to April 30, there will only be 29 periods. Okay, I hope that's clear. Yes? Did that answer your question, Diana? Okay, thank you. It depends on the problem. My question, this is Daniel. Do we need to solve for both? Daniel, kindly share your question to everyone, please. Daniel? Yeah, okay, thank you. So it depends on what's being asked by the problem. Okay, if you're asked to solve both, then we solve both. But the difference is very easy. It's only with the divisor. Okay, and we know that the ordinary interest will always be higher than the exact interest because in the exact interest you're using the higher divisor, which is 365, but in ordinary you're only using 360. Okay, So everyone, please kindly chat if we're okay. Clear ba tayo so far? Are we clear with the computation for exact interest, ordinary interest? Okay, feedback, please. I would appreciate your feedback. Thank you. Please tell me if I'm going too fast. Sometimes I might forget that I'm going too fast. Okay, good. Thank you so much. Okay, so my question, Vito, if it's not stated, is to go to interest, ordinary, or exact? It will always be stated if we want exact or ordinary. Sometimes the context will be given. So for example, if you're told that it's in banks, no, then it will be the ordinary. If it's the government, then it will be exact. But we will not create a confusion there. I will tell you if you need exact or ordinary. However, class, when we're speaking of rates, it's always assumed to be annual. Okay, do not assume that if it's daily because the time given is daily. Okay, the rates will always be assumed to be annual unless I'm saying that 3% per month. Okay, when I say 3% per month, then that means that's monthly. But if I just say 3%, then automatically that is annual. Okay, so we looked at this ordinary interest. All right, so here the difference will be in the, okay, this is another example. Okay, so let's copy this, Control C, and then just as an exercise. Okay, same thing. So this is from May 4 to August 10. All right, May 4, August 10. Okay, just for practice first, no? From May 4, okay, May, and then April, June, July, August. Okay, so let's see. How many periods are there from May 4 in the whole month, starting with May 4? Here you can subtract, as we learned a while ago. So 31 minus 4, that's 27. There are 31 days in May, and since we're starting with 4, if we count actually the number of days from May 4 to May 31, that will be 28 days. But since we're counting the periods, so that will be 28 days minus 1, okay? Or May 31 minus May 4, so that's 27 days. For April, again, 30. For June, wait, May, oh, sorry, I'm mistaken. There should be no April. So May, and then June, and then July, and this is August 10. Okay, so that will be, okay, 10 also. Why 10? Because we do not subtract August 10 to August 1. Otherwise, that will only become 9. We have to include the previous July 31 up to August 1. That's also one period. All right, so days here, days will be just the sum of this one. Okay, so that would be 98. If we're using Excel, that would be very easy. August 10 minus May 9, May 8. This will give us the exact number of periods. Take note, this is the number of periods. Okay, so let's compute. The P is 15K. The rate is at 8%. Let me use capital here. 8%. Okay, and then let's say exact days, 365. Ordinary days should be 360. Okay, and then I can use here, take note. Okay, I can use here Control Alt, Control Shift F3. I can give these names: PR, exact days, ordinary days. Okay, and wait, let me also insert here. Let me just insert here the days. We can include it as a name. Okay, so I included here the days so that it can be part of the named range. Control Shift F3 there, and it rightly guesses that the names are in the left column. Okay, all right. And if you look at this one, it now has a name P. All right, this one has a name R. Okay, and you cannot use single, so it's giving it R underscore. All right, so our interest. So let's put here exact. And on this side is ordinary. And maybe we can put it side by side. So for the interest, for the exact, it will be equal to P, note, times R times RT, these are days, divided by our exact days. There. Okay. So that will be 322.19. For the ordinary, it will be P times your R times your days divided by your ordinary days. There. So one good thing here is that you can see the the name itself, and the maturity value. Okay, we can use just the sum equal to P plus the interest. We didn't give this a name. We can copy this here. Okay, so again, let me pause for a while. And I'll entertain questions. I'm sorry, I might have been going too fast. No? But this is just another example to reinforce what we just did a while ago. I'll share this Excel spreadsheet with you. Okay, any questions? Any clarifications? Okay, once again, please bear with me if I always keep on asking, is it clear? So feedback, please, if clear so far. Your example on exact and ordinary interest. Okay, good. Thank you. Thank you. All right, did you get the same answer? 322.19, 326.67. Let me check. 322.19, 326.67. Okay, so we got the same answer for this one. Okay, Now, sometimes you're not being asked for the interest. There will be problems where you're given the interest, and then what you need is to compute for either the rate or the time. So how does that work? You can use this mnemonic device. This is just a mnemonic device. See, naghang yung my digital pen hand. So that's a problem sometimes. There's a conflict between the mouse and the digital pen. Okay. All right. So let me just write here. Okay. So this is just a simple mnemonic device. Okay. So how does this work? Okay. You know the interest, and you either compute for the principal, for the rate, or for the time. So if you're going to compute for the principal, you have to know the interest, the rate, and the time. So this mnemonic devices tells us if you're computing for the principal, then the formula is I over RT. So that's simple. If you're computing for the rate, and the formula will be I over, so we remove R here, it will be PT over PT. And then if you're computing for the time, it will be interest over principal times rate. Okay, so that's a very simple mnemonic device. All right, so let's copy this problem. Let me copy this to Excel. So interest was given at 19.48. Okay, interest 19.48, and then rate is at 9.5%, and then time is 90 days. All right. So you're given the interest, the rate, and the time. Then we're being asked to compute for the principal. How much did Tim borrow using ordinary interest method? Okay, so as I mentioned a while ago, if you want to use a mnemonic device, then it will look like this. Interest, and then this is your PRT. Okay, this is your mnemonic device. So if you're looking for the principal, it will just be interest over rate times time. So that's how simple it is. Okay, so P, that's what we're looking for. P is let's put here. Let me just put ordinary 360, because we're told that the interest was computed based on ordinary days. Therefore, our principal is interest over R times time, right? So we're given the interest divided by the product of R times time. Now take note, R is annual, therefore your time should also be annual. So if you're given 90 days, you have to divide this by the number of days per year. Since it's ordinary, we're using 360. Okay, so enter. Therefore, the principal was the principal was 320.5 0.2. Okay. Let me pause for a while. And for those of you who are also doing this, let me give you time to do that. And also let me entertain questions if you have any. Are there any questions about that problem? So these are very straightforward problems. In fact, you don't really need this mnemonic device, but if it helps you, then why not? Okay, let me once again ask for a feedback. So far, class clear in solving for either principal given the interest, you just divide the corresponding product of rate times time to interest. Okay, if you're looking for the rate, then interest divided by principal times time. Okay, any feedback? Clear so far, class? Okay, thank you. Okay, good. Good. Okay, this time around, you're asked for the rate. So let's copy this. These are just similar problems. Okay, good. So same problem. You're given this time the principal. You're given the principal. You're given the interest. Okay, the question is, sorry, you're given the number of days, 90 days. What rate of interest? You're asked for R. So if you're asked for R, right? If we're asked for R, then the formula will be interest divided by P times T. So let's copy this. Control C. So instead of R, what we're given is the principal. And the principal is 820.21. Okay. All right. So what we're looking for is the rate. We're looking for the rate, and very simple in this mnemonic device, it's I divided by PT. Okay. So that's interest divided by quantity, the principal times the time is 90 days, but we have to convert that into year. And since it's an ordinary interest, so that's 90 divided by 360. And we should be getting this rate because it's the same problem. So that's 9.5%. Okay, so the same. All right. Again, once again, guys, let me pause. Okay, and ask. So far, computing for the rate given the interest, the principal times time. That's pretty straightforward. Just divide, and you guessed right. The last question here will be, so that's 19.5, 19.48. Okay, you guessed right. The last question here will be finding the the last question will be finding the time. Okay, so same thing, guys, time will be equal to interest divided by principal times rate. Okay, thank you. Thank you for your feedback. And same thing, I won't do this anymore in Excel. So this is your interest divided by principal times the rate, and it gives us 0.25. Now take note, the time will be in years. Okay, the time will be in years. So since the time will be, the answer will be in years, and since we're interested in knowing the number of days, okay, how long was the loan using ordinary interest method, then we multiply the years by the number of days per year to get the number of days. So 0.25 times 360. If it was using the exact, then it would have been 0.25 times 365. Okay, so far what we have done is to learn how to compute for the exact interest rate. We also learned how to compute for the ordinary interest rate. We have learned how to compute for the maturity value by adding the principal and the interest. We also learned about the combined formula for maturity value, which is principal times the compound rate, the interest rate of 1 plus RT. And then we learned to compute for the principal or the rate or the time given the interest and the other corresponding values. Okay, so far, class, that is what we have learned. All right. Now, just by way of information, time over 1 year, a number of days can either be 360 or 365. For weeks, we use 1252. Of course, for months, we use 12, and quarters, we use 4. Okay, let's take a look at the next. Now, sometimes, if you have a debt, okay, and you might wish to pay ahead of time, okay, so you may want to pay off a debt in more than one payment before the maturity date. Okay, I don't know what's happening to my laptop. Okay, some loan agreements allow the borrower to receive proper interest credits. So this means that we're going to have a partial loan payment. Okay, when we have partial loan payment, then we will have to compute the interest that has built up. Then the remainder of the partial payment reduces the loan principal. Okay, so this is a case where you have a loan, and then the agreement allows you to pay off a certain portion of the debt, okay, before the maturity. Okay, how do we do that? How do we compute for the payment? All right, so let's take a look at this example. We're asked to calculate the simple interest and maturity value for the following problem. So first, the principal is 9,000. The interest rate, which is of course annual, is 2.25%, and the term is 18 months. Okay, the simple interest is 303.75, and then the maturity value is 9303.75. Of course, this was computed. Okay, this was computed. So let's see. Let's just validate that. Let's go here. 9,000, 2.25, 18 months. Okay. So we have here the principal is 9,000. The rate is 2.25%, and the time is 18. So this is 18 months. Okay. So first, let's compute for the interest and the maturity value. Okay, so simple interest. All right, so the period is in months, so no need to know if it's exact or ordinary, because exact and ordinary will only be used if the days are given. All right, so this is in months, just to clarify. Okay, so we know how to compute the interest. It will simply be the principal times the rate, okay, times the time. So 18 months, we have to divide that by 12, okay, to convert it into years. Okay, so this is your interest. And then the maturity value will simply be the principal plus the interest. Okay. So this is the interest payment, 303.75. At the end of the 18 months, the borrower will pay 9303.75. Okay. So this one, we were able to do that. All right. How about this? Okay, this is just an example. All right. How about this? Complete the following using ordinary interest. So principal, interest rate. This is just another example. Okay. Right. So let me just flash answers because I know you can easily solve this. The principal, interest rate, date borrowed, date repaid. We will just have to count the number of days, and then if you count the number of days, that's 93 days, and then we can compute for the interest. So the interest will be equal to P times R times T. Principal is 1,000, rate is 8%, and the time is 93 days divided by 360, since we're using ordinary interest. So the interest is 20.67. Therefore, the maturity value is adding your interest to your principal. So that will be 1020.67. Okay, so these are just reinforcement problems. Any questions about this class? For this one, I think no. For this one, I think there should be no problem because this is pretty straightforward. And then for this one, it's just using the ordinary interest, which means this is divided by 360. And then for another problem, also the same, but this time is exact interest. So for exact interest, we're using 365. Okay, we're using 365. So we are able to compute for the interest and then add that to the principal, we have the maturity value. Okay, I don't think I included here the early payment. Okay. All right. So for this one, exact interest, yes, I already discussed this. It's the principal times rate times the days divided by 365. Okay. I don't think I have posted this slides yet. No? Let me check. Did I already? Under modules. Yeah, the simple interest is already here. Oh, why is this not yet published? Sorry. This was the September 6th session we had. And yeah, I'm sorry, I forgot to publish this. So it's now available for those of you who missed the September 6th class. Okay. All right. The other example here will just compute for the time, given the interest, the principal, interest, the rate, and the principal. So that will be simply I divided by P times T. So this interest divided by the principal times the R. That will give us the number of periods. Okay. So what this gives us is the number of years. The time will always, when we solve for time, it will give us the number of years. So it depends on if you're asked for the number of months or the number of days. All right. So that takes care of the first set of slides for simple interest. Now I think I forgot to put here this one. Okay, let me just include some additional slides for simple interest next meeting. But now let's just start with this one, simple discount, and I'm going to share this also with you. Okay, so far what we have discussed is simple interest. I still have a few more minutes just to introduce this topic, and then we're going to continue with this discussion next Friday. All right. So what are objectives for this discount? Simple discount. What we learned was simple interest. So this is simple interest versus simple discount. So we're going to learn the difference between simple interest and simple discount. And we're going to look at promissory notes. Promissory notes, mga IOU yan. I promise to pay. So we're going to learn how to differentiate between interest-bearing and non-interest-bearing notes. So a notes, as the name suggests, it's a writing, it's sort of a mini contract that you're promising to pay such and such. We're going to learn how to calculate bank discount and proceeds for simple discount notes. Okay, compare the interest, maturity value, proceeds, and the effective rate of simple interest notes with a simple discount note. We'll take a look at the difference between a simple interest note and a simple discount note, and explain and calculate the effective rate for a treasury bill. Okay, and then letter B, we're going to calculate the maturity value, the discount, and the proceeds of discounting on an interest-bearing note before maturity, and identify and complete the 4 steps of the discounting process. So our next lesson will be all about discounting. Okay, about discounting. So when you're dealing with interest-bearing notes, it has to state the rate of interest. Okay, if it states an interest of 9% when the note matures, the corporation will pay back the original amount borrowed plus the interest. Of course, we know this. When we borrow, then we receive the amount, which is called the principal, and then when the maturity comes, we pay it back. We pay back the principal plus the interest. Okay. On the other hand, if it's this is for interest bearing. For non-interest bearing, okay, non-interest bearing, then it means no interest. So if you borrow 10,000 during the maturity, let's say after 1 year, you pay back just 10,000. Maturity is the same as the face value. It usually occurs for a short time period and under special conditions, because nobody will lend without an interest. Okay, so this is an example. I'm sorry the picture cannot be shown. I have a problem with problema sa PowerPoint ko. No? Okay, so all right, it's time, but just this last slide. Okay, So for a discounted amount, what happens is that you borrow, okay, you borrow a certain amount, and then what will happen is that the bank will automatically deduct the interest. That's called the discount. Okay? So if you're borrowing 10,000, you're not going to receive 10,000, but a certain amount lower than that. Okay? That's what we call discounting. So if you borrow 10,000, you might be getting 9,800. Why? Because you deduct from the principal or from the face value the discounted rate. So that's what you call the bank discount. So if I'm borrowing 10,000, I won't be getting 10,000. I'll be getting, let's say, 9,800. And then at the end of the term, let's say 6 months, I will have to pay the 10,000. Okay? So let's stop there for a while. So for the next meeting, we're going into this, a difference between the maturity value and the proceeds. So simple interest, simple discount. For simple interest, we add it to the principal to get the maturity value. For discounting, okay, we subtract from the maturity value the discount, the bank discount, where we get the proceeds of the loan. Okay, let me stop.